Hello, everybody. My name is Joe Russo, and you are tuning into another South Florida Tech Talk. Thank you so much for everybody who is joining us here today. Going to share my screen and give a brief presentation for all those who can join in and see it. This is another in a series of online events we've been doing that typically happen in person. All of our tech talks are usually in-person happy hours that we're now doing online. So we're going to be hearing from Disaster Management Group today, talking about smart video technology for object detection. And we have Cam Collins and Anatoly who are going to be diving into that. But really briefly, just to introduce the talk today, Palm Beach Tech is an organization with one simple mission: building South Florida into a tech hub. This is what we do. This is why we wake up in the morning. This is why we have events like this to encourage and deepen the passion for our tech industry here in South Florida. I want to introduce our sponsor here for tonight, Carrie Stamp and Company. They are financial advisors. They also have a tech startup themselves. Rob Taylor is here to briefly introduce the company, and just want to thank them for supporting this program and everything that we do. So Rob, if you want to come off mute for a second and tell us a little bit about more what you guys do.
Thanks, Joe. Appreciate it. So we are a wealth management firm. We're based out of DeQuesta, Florida. We work with individuals, businesses, really just helping them get their financial lives in order, whether it's wealth management, tax planning, estate planning, business succession planning. And we have recently been really trying to get more into the tech side of marketing. We've been doing a lot more blogs. Carrie's been doing a lot of really neat videos that if you guys want to check out, you can go to our website, carriestamp.com, and take a look at some of those videos. We're also involved in the FAU Tech Runway program, where we're developing an app called My Smart Uncle. It's designed to help anybody, but probably geared more towards millennials in terms of teaching them how to invest, giving them advice on various things like how can you deduct, how can you get tax deductible contributions to an IRA, how can you just do some very basic things kind of getting started. So if you guys ever want to reach out and hear a little bit more about that, we'd love to get your feedback because we're just getting that off the ground. So with that, Joe, I'll turn it back to you, and I appreciate the plug.
No, thank you very much, Rob. And believe it or not, me and Rob are also in the same leadership Palm Beach County class this past year. So shout out to that organization. I want to move forward real quick so we can dive right into the presentation. For those that don't know, we are a nonprofit organization. We have over 200 plus members. We exist to build South Florida into a tech hub, and there are plenty of amazing companies and businesses that have chosen to work with us. So shout out to some of these great organizations for supporting all of our efforts. We do have a number of membership benefits and plenty more. You can go to palmbeachtech.org to read more about them. And as always, we do have a community creed for all of our events that says we are wholeheartedly committed to building a welcoming, collaborative, and inclusive community for all. And this includes our board of directors on down. So do take a look at that and see this is something we talk about and put on all of our programs and events. That said, we do have a number of other things that are going on: community coffees, podcasts, workshops. You can find more about this on our website as well. And if you're looking for a new gig, a new job, a new opportunity, you can go online and submit your resume to our website. Go to palmbeachtech.org/careers, and you can drop down to the menu there and submit your resume to all of our hiring companies. Also, we do have a Slack channel. You're more than welcome to go to southfloridatech.com/Slack and join it, with over 3,700 members and counting right now. So, we're obviously doing a pretty bang up job trying to bring the community together. And, the more we get the word out, that's how we do it. So with that, I want to recognize the CTO of Disaster Management Group, Cam Collins. He is a lifelong Floridian and a longtime member of our organization with a couple different organizations, now most recently Disaster Management Group. And he's the former co-chair of the Palm Beach Tech Association. So Cam, thank you so much for being here tonight, presenting with us, and look forward to the presentation.
You bet, Joe. Thank you. I appreciate that. And I appreciate everybody being here as well. A great turnout tonight. And one of the things that I really like about a lot of the folks that have come, we've got people who are from industry here, but we've also had people who are here just to learn and find out more about, whether it be object detection or AI or machine learning in general and that kind of stuff. So I think that's really, really neat. As far as being able to share my screen, let me go ahead and get that cranked up here. Just give me 1 second and we'll kick it off. All right, let me know if everybody can see the very first slide, smart video technology for object detection. Okay, great. So it's funny what Joe was saying before. I've been involved with disaster management group now for actually about 8 months. Prior to that, I was running a software company called DocMaster Software, and so I am actually new to AI. I've been deep into machine learning and AI now for only the past 8 months. I'm not going to tell you about my graduate level AI course I took about 30 plus years ago. It's irrelevant at this point in time. And what blew me away about the whole AI world is how much things have changed, especially in the last 5 to 10 years, but certainly over the past 30 plus years when I was studying electrical engineering and computer science. So what I wanted to do today is, Monica and I thought it'd be a good idea to kind of give everybody sort of a backdrop first, to start a little bit, a conversation around, what is AI compared to machine learning and deep learning? How are they different? Where do we find AI today? And then we'll talk a little bit about some of the applications that AI is utilized for, and specifically the application that we're working on now. I'll give you an introduction to that, and then I'm going to introduce Anatoly, who is the individual who's doing most of the research around the new technology that we're looking to bring to market. And his presentation really is a summary of what he will be presenting at the FAU Data Science and AI conference this Saturday. Which we were absolutely thrilled to be asked to be a speaker at that conference. So I'm going to start off now with just talking about machine learning specifically and how we find it in everyday life. We're seeing, especially over the course of the past couple of years, machine learning finding its way into almost everything we do when it comes to our gadgets or when it comes to our devices. So you've probably noticed over the past couple of years that as we take photos and those photos get uploaded to a place like your photos on your Mac or your photo gallery in Windows, that the technology is now getting better and better at being able to label those photos. Like people who are close to you, people who are friends with you, these image processing systems can now actually label them as mom or dad or Jim or Steve or Sally. That's machine learning that's actually doing that. This image recognition and classification. Same thing with audio sensors and audio detection. So, for instance, I'm sure many of you, if not everybody on this call, either has an Alexa device or they've got an iOS device or a Google device where you simply say, "Hey Siri" or "Alexa" or "Hello Google." And those devices literally light up and said, "Oh, what do you want?" My phone just chimed back and said, "What do you want, Cam?" Right. So that's that's AI, and that's audio sensor and audio detection, and understanding that the device is effectively being woken up, it's recognizing what you're saying, and then now it's waiting for the next request. Same thing with social media. As you're on Twitter, Facebook, LinkedIn, wherever it may be, and you're liking and commenting and disliking other things, you are effectively building you're telling the machine learning algorithms with those various social networking applications what you like and don't like, so that in the future it can predict what type of content to serve you. And I'm not sure if anybody on this call's actually seen the movie Social Dilemma, but it does a really, really great job explaining actually how this works and sort of kind of the good and bad side of this, and so some of the negative downsides of this, and how it could potentially negatively affect things. But anyway, these are things we do every day, we see every day, and we're involved in every day. And machine learning is in our lives, and it's certainly here to stay, and it's going to expand. The next slide talks a little bit about sort of how do all these different terms fit in. So you kind of think of artificial intelligence as sort of being the large field of study around making computers smarter, and then are having the computer and or the program be able to actually make decisions based on input. Well, machine learning is a subfield of artificial intelligence, and it's really focused on developing algorithms that can learn to solve problems by analyzing patterns in data. So machine learning wants lots of data, and you feed it data, it analyzes those patterns, and then it should be able to accept data in the future and make decisions based on that data. Deep learning is actually a subset of machine learning, and deep learning uses a very specific type of algorithm called a neural network. So deep learning leverages neural networks and large amounts of data like machine learning, but it really, really cares about lots of data. Usually, the more data you can feed a deep learning algorithm, the better that algorithm performs long term. And years ago, the impetus for artificial neural networks actually was inspired by biological neural networks. So this simple diagram shows what a cell may look like in your brain, or a neuron. And the dendrites are those those receptacles out there that are getting input and information from various cells in your body. The information gets processed in the nucleus, and that information gets then passed on to through the axon to other terminals, and it gets fed to another cell body where the information is passed on further and further and further and further refined. The impetus for neural networks was developed based on this model. So you can effectively mimic the primary function of a human nerve by producing a function that receives a list of weighted input signals, and then it runs it through an algorithm, effectively outputs a signal that is really the sum of those weighted inputs with a certain type of bias. Bias meaning that we're only going to output a certain amount of data if it reaches some level, like true or false, for instance, at the most simple level. So one type of neural network that Anatoly is going to further describe today is actually called a convolutional neural network. And this problem that I'm showing now about being able to decipher photos and doing image classification between a cat and a dog used to be a really super hard problem to solve. Interestingly enough, with modern technology using TensorFlow and Keras, you could probably now build a pretty good neural network with about 20 lines of code to do this. But this is a pretty good example of what a simple neural network might look like. So I'm going to try to draw some pictures here to sort of show you a little bit. So it's taking effectively one input, and it's either a photo of a cat or a dog, and it's running that photo through what we call hidden layers here. And these hidden layers eventually produce an output layer. So in neural networks, you hear about the input layer, you'll hear about the hidden layers, which can be very, very numerous, and then the output layer. And the whole point of convoluted, the reason they call it a convolutional neural network is because the computer actually takes these images and effectively convolutes them into bite-sized chunks that a computer can understand. So a deep learning algorithm really takes this input image and assigns levels of importance, i.e. learnable weights and biases, to each of the little segments of the image. So it can literally come across, and it's called stepwise movement across the image, and find little bits and pieces of the image that are relevant. And when it comes across a piece of that image that distinguishes the cat from the dog, it may have a higher weight than something like a blank area or something that is that's non-distinguishable between a cat and a dog. And one of the concepts behind neural networks and actually all machine learning really, is you feed a algorithm a set of labeled data set. So in the case of the cat-dog problem, you're feeding it a set of labeled images. So let's say we have 8,000 images in our training set. They're all either labeled cat or dog. We feed that into our neural network as a training set, and then the machine learning algorithm gets smarter and smarter based on by the data that it's fed. Then we could then take a subset of that data. Let's say there's another 2,000 images that are still sitting out there that we then feed it to the neural network unlabeled, and then we test to see whether those images, whether they're right or wrong. If I put a cat image in the neural network, did it output cat or did it output dog? And then we test just to see how well we what's called trained our algorithm. So at a very, very high level, that's some basics about deep learning and effectively a convolutional neural network, which is what we used to build our object recognition module, or I should say algorithm. So given that as a backdrop, we then said to ourselves at a disaster management group, can we use machine learning to improve safety or improve our disaster response planning? We're in the business of effectively providing disaster management facilities, disaster management services to any entity, organization, government, wherever it may be, who has been affected by some kind of natural disaster or man-made disaster. So a classic example would be hurricanes. Hurricane hits a particular area, we come in with temporary housing and temporary hospitals and clinics to provide support and relief for either first responders or actually those citizens. We've been very, very busy during COVID because disaster management has been one of the leading providers nationwide to actually create quarantine camps for the U.S. Army specifically. And I'll talk even in more detail about a project that we're working on now with COVID vaccines. But so having said that, we wanted to look at, okay, what else can we provide as a technology service to better to build more of a complete wraparound service or a full suite of solutions for our end clients, whether they be users of our Basecamp services or medical facilities or what have you. And one of the problems we actually stumbled across was contact tracing. I'm sure most of you have heard of the term contact tracing or object detection. And contact tracing is a really interesting problem if you try to automate how you track contacts and contact instances. So contact tracing, there's a couple of different solutions to effectively solve that problem or attempt to solve the problem now. So what are some of those? One of the most popular solutions you hear about today is utilizing mobile devices and Bluetooth. And it's a fairly ubiquitous technology because almost everybody has a smartphone nowadays. But there's a couple of problems that occur that are really inherent in the Bluetooth model. One of them is that you need to have strong Bluetooth signals for the technology to really work well. If you get a weak Bluetooth signal, or if the phone is in someone's back pocket and they come within 2 meters of someone and there's a low signal and it's not being picked up by the repeater, and then they go away, you may miss a contact instance. You also need to have device compatibility. People need to download an app. They need to have the app installed and working. And honestly, some people still don't have smartphones, especially, like my father-in-law does not own a smartphone, refuses to buy one. So he's now outside of that population of people who could utilize this technology. And the sort of the last problem with this is that you have sort of the sign-on compliance. Did you sign on to the app? Oh, I forgot to sign on this morning, or I never signed on right, or what have you. So there's lots of potential problems with a Bluetooth-enabled solution. Even though Apple and Google had a huge announcement about this and they've been pushing the technology, they ran into some privacy challenges with it. There's been kind of challenges with this going forward because of it really requires buy-in by the end user. A better technology that we've run across here recently is actually using IoT devices or wearable devices. And we actually built integration to one of these technologies in a Salesforce app that we built. The wearable devices solves a few of the problems that Bluetooth can't solve. Number one, once you put that wearable device on, it works. And we found the accuracy level with these wearable devices to be really good. So you don't have to think about, am I near a Bluetooth device? Is my Bluetooth on? Did I log into the app? It's always on. You wear the device, it's always on. And they're also very, very small. There's an image here that you can see is one of these wearable devices from one of our partners in Gainesville, Florida, that makes these called alert trays. And that's literally the size of the wearable device. So it's a low power draw, little coin battery type of deal, and it's small and compact. But there's still problems with this as well. Wearable devices are invasive. In other words, they have to have the device on for it to work, obviously. And number two, you have sort of a challenge too if you're trying to manage contact tracing at a large event, is because you've got to you have to dole these things out. You need to assign these devices to users, you need to activate them for those users. And if the event is not a long-term event, then you need to collect them back. You've got to sanitize them, reset them, and then give them out to the next set of users. So there's kind of some device challenges around just sort of the whole management of the devices themselves, especially for events that are not long-term, like a football game. If you're going to hand one of these to everybody who walks into a football stadium, then collect them all back at the end of that, or a golf tournament or whatever, you're dealing with lots of challenges. So we decided to solve this problem, obviously, by way of the title of the talk, by using smart video technology to detect proximity, object proximity. It's a really challenging problem, and we're getting close to having some really good success with it. But we've decided to make the solution completely non-invasive in terms of requiring some kind of device or requiring some kind of app to be downloaded on a mobile phone. If you're in an area where where it's an area where a large group of people are going to be coming together, there's video surveillance cameras that detect two or more objects, i.e. people. So I just showed you the image recognition. It needs to be able to distinguish a person from a chair or a cat. And then it needs to be able to do facial recognition on those individuals. And then it needs to detect two individuals that come within 2 meters of each other for 2 minutes or more. And you can tweak these if you want to. You can make it 1 minute or more. You can make it 1.5 meters if you want to. But this is a challenging algorithm to solve for, a challenging problem to solve for. But it was the most non-invasive solution that we could think of, and it works really well with a couple of different use cases that we have in mind to deploy this. So let me go ahead and show you one of those now. Disaster Management Group is one of a handful of vendors that were contracted to build mobile vaccine centers for Operation Warp Speed. And this is what they look like. They don't look too much different than those of you who remember having, like the portable classrooms when your school started to get too crowded. ADA ramps, people can go up with a wheelchair or some kind of or crutches, whatever they may be. So we had to have approval for all this stuff. But these mobile and portable units actually provide for administration area, examination, phlebotomists, and vaccines. Now, there's a contact tracing problem that are inherent in these types of facilities. Number one, you've got queuing areas. You get people who are queuing up, waiting to get in the unit on this ramp potentially. You've got a waiting room that this little image shows here. People sitting in a waiting room and maybe getting up and using the restroom or walking around the hallways. And we're in an environment that really needs to be monitored in terms of contact tracing, especially if these are being used for testing. So we envision being able to use these cameras and this video surveillance technology in units like these to do contact tracing, as opposed to handing every single person who walks up to the unit a wearable device. Another use case, this is the original use case we were trying to solve for, is in the cruise ship industry. Cruise lines, as you probably know, since COVID, have effectively been shut down. In the United States, it's a voluntary shutdown. While they're getting all of their preparatory work done to submit to the CDC to be approved to cruise again. So the CDC's already said, submit it and you can cruise. The cruise industry is voluntary, so we want to wait longer until we get all the protocols in place. But as any of you who've been on a cruise, you know they can be like super spreader events from a COVID perspective. This is a little bit of an over-the-top picture of a pool area and a deck on a cruise ship. And you've got all kinds of challenges on a cruise ship with wearable devices that can get wet or someone forgets to wear them and what have you. So could video technology be used in a case like this? And the answer is possibly. So here's some slides kind of showing what that use case might look like. You could have people who are staying at a cabin. They already are a known resident. So in the system, we know that person A and person B are already together. So don't track a don't track a contact instance with A and B. But person A may go out to the pool area and maybe near the bar or near the lounge or whatever, or sitting next to someone or dancing with somebody, and they're creating contact instances. So there's a contact instance between person C and D with person A. They may go to the restaurant later and also have contact instances that take place. Then they go back into their cabin with person B. So what if now person A goes down to the medical facility at the ship and says, "Hey, feeling symptomatic. Hey, not feeling well. Can't taste my food. Sniffling, whatever it may be," and the person either tests COVID positive or they wake with symptoms. We now need to be able to do a contact tracing. We need to be able to run a report to find out every contact instance that an individual may have come across since they've been on that cruise ship. We know that person B is their suite mate, so that's okay to not choose and not select them as a contact. They're an automatic contact instance, right? Because they were together. But who are all of the other contact instances that they came in contact with? So this is the use case that we're trying to solve for. It's a super challenging one on a cruise ship because a cruise ship has to also not only is not connected to the cloud readily. But having said that, that's sort of a different technical challenge. But I wanted to just bring about what some of the use cases look like before I hand things over to Anatoly to give you more of a deep dive into how we actually solve this problem from a machine learning and deep learning perspective. Okay. So Joe or Monica, could one of you be able to forward the control over to Anatoly, or is that something I actually do from my side?
Hey, Cam, you could just do that on your side.
Okay. All right, Anatoly, I think you're live now, sir. Anatoly, you need to unmute. You're still muted. Hmm. Joe or Monica, I'm not sure that we can actually unmute him. That's one thing are you trying to unmute yourself, Anatoly, and it's not working? There we go.
Yeah, I forgot, sorry. I forgot to unmute myself. I'm going to give you some technical details about the application that we are developing for this video tracking, detection, and measuring distances between people using MATLAB tools. MATLAB is a very well-developed modeling and simulation tool, and we use MATLAB as a major platform now, but it can be moved to another platform like Python or C++ or whatever. So the data is taken with the camera, it's a surveillance camera, and then the user stores the video data, and then the processing starts. We do video segmentation, finding object that we are interested in tracking. And then these are people, and we have to detect faces of those people in order to recognize the people. And then we have to do labeling and cropping labeling of this facial images. And the next step is actually feature extraction. Feature extraction is well, exactly what Cam described as as an example of the feature extraction as a convolutional neural network, but there could be other feature extraction algorithm used in this. And we built a image database that we use for training the classifier and for identification of the people in the scene. A very important part of this procedure is calibrating the camera, because especially when you use a video surveillance camera, they have lots of aberrations and distortions, and sometimes the quality of image is not good because illumination varies and the distance between the camera and the people who we want to recognize varies a lot, and the quality of image can be very poor. So we use camera calibration to improve quality of the image and to provide what's important is calibration is also used to provide so-called ground truth for depth measurement and for measurement the distance between the people. Actually, I use my door, the door that is behind me, is ground truth. I measure the distance, I measure the size of the door and distance between the door and the camera. And I use this information to, oh, sorry, that's Mac. It's a different kind of manipulation I have to use, not the same as the PC. And this is the result of measurements using the ground truth that I acquired during the camera calibration. And the distance, you can see the distance becomes shorter than 2 meters and some instance, and it remains shorter than 2 meters for 96.6 seconds. And the measurements show that. And this is an event that we have to record, and we have to save a record of it. We use different algorithms of pattern recognition. And finally, we found out that if we have many classes, we have to use this convolutional deep learning neural networks. The important part of all this procedure of face recognition is to build a proper database. And sometimes building a database is more important than using a proper algorithm. And with MATLAB labeling application, we can do it pretty easily, because MATLAB has tools that are built and can be used almost as is with minor tweaks. And this is the result of face labeling, face tracking labeling, and recognition. It's just me and my wife. And you can see that, the program recognizes Anatoly and Olga, but sometimes some spurious faces appear in the scene, but those spurious faces can be easily filtered out by the algorithm, and they don't count when we calculate the distances between people. So the test results show that with the one of the algorithms that we use at the beginning is histogram of oriented gradients for 40 classes. It accuracy of provided accuracy of 97.5%, which is good enough. But we wanted to have more classes, and this is why we switched to a deep neural net classifier algorithm. With the neural net, it's one of the possible neural net, deep neural network classifier, which is called AlexNet, and which is fully implemented in MATLAB. We could manage to train the classifier with 73 class mixed phase images, image database, and we achieved the accuracy of 98.5%. It looks good, the first glance, but unfortunately, there are some persistent errors that we couldn't avoid. For instance, this person could never be recognized as correctly. And it means that we have to work on the classifier to improve it, and there are several means how to improve that. For instance, one of the possible applications, possible means to improve classifications, so-called transfer learning. When we pre-train classifier and then use this pre-trained classifier with a new set of images, new image database, and it can improve accuracy and it can improve speed, and it can work with more classes than, say, regular convolutional neural network. Finally, as a summary and conclusion, we have to work on some problems that we encountered on the way of building this application. First, it's noisy, low resolution, and low contrast surveillance video input may require pre-processing to enhance contrast, to enhance and improve quality of motion blurred pictures and the defocused pictures. And another thing that we can do, we can try it, that MathWorks that offers MATLAB, MATLAB simulation package can provide improved video processing based on their cloud service. And this improvement can be especially effective if we use a container for NVIDIA GPU cloud of MathWorks. And this is about it. If you have any questions, please ask.
Yeah, so if anyone wants to, you could actually come off of your mute and video if you want to ask questions to Cam or Anatoly, and just you can put your video back on, put your audio back on.
Okay.
That was definitely the summary version of that presentation too. If you want to hear the full presentation, Anatoly, I guess they could, someone can certainly join, right, on Saturday for the FAU conference.
Mm-hmm.
Yeah.
Oh, how can I get off?
The very top.
Share screen.
The top
Oh,
share.
the very top. Okay. Yes.
And Joe, I'll put a link to the FAU conference in the chat too. So.
Perfect. Thank you. I was just actually looking for that myself. So yeah, this weekend, the FAU Data Science and Analytics Conference. It's obviously online. I believe this is the 3rd or the 4th annual. As a baseball fan, actually the CRO of the Miami Marlins is going to be speaking as well, amongst several other representatives from companies and or organizations around the region. So do take a look at that and tune in. Anybody have any questions for on the presentation?
I think I have a question.
Sure.
Go ahead,
Does your
James.
approach to use Internet of Things to offer services whenever a disaster comes in?
Man, there's so many possible IoT use cases in disaster management. It's really, really amazing. I don't know where to even begin because the opportunities are kind of limitless. So we have, I'll give you a good example. There's a company that we work with that is effectively a crowdsourced AI group. And they built an application for a company down in Brazil. And they use these IoT devices in the Amazon to detect forest fires. They do a combination of that along with kind of this heat sensing technology across large swaths of Amazon rainforests. But there's ways to actually, I don't know all the science behind it, sorry, but the ways to actually detect that a small fire started in the middle of nowhere, but they have enough devices to be able to do this, and then be able to triangulate where that outbreak is and get to it as opposed to just letting it kind of burn out of control, right? So there's lots of different possibilities there. Now, one of the things that we're looking at is, and I don't know if this is specifically IoT related, but actually how to better gauge supply chains when disasters strike. So another project we've looked at is there's lots and lots of historical data about tropical, or I should say cyclones worldwide. So how do you take all that data across all those cyclones that hit around the world and figure out, okay, what areas were impacted? Where were the most low-lying areas? What's the demographic of those areas? Where there's some serious challenges in terms of food and water supply? How do we circumvent those supply chain issues in the future and those kinds of things? So quite a number of possibilities.
Awesome.
And with that, we are sadly at time, and I know to be respectful of everybody here, I do want to try and put the boundary on time for a second. But for those who are tuning in, for those who are live, you can learn more about this. You can find Cam Collins and Anatoly on LinkedIn. They put their information on the chat here, and do take a look at the FAU Data Science Conference this weekend. It'll be really great and educational. And Cam, where else could people go to find more out about DMG?
Yeah, I'll put a link to that as well. But basecampservices.com is our website, and we're just actually next couple of days we'll be posting some new information about the rollout of these vaccine centers across the country. So pretty cool.
Awesome.
Yeah.
Well, thank you so much to everybody for tuning in. Thank you so much, Cam, and DMG for taking part here and for being members of the organization. And I hope everyone has a good rest of your week.
Yeah, bet. Thank you, Joe. Take care.
Have a good one.
Bye.